Recent advances by scientists and engineers in manipulating matter at molecular magnitude indicate potential contributions for applications of this nanoscience through developments of materials and systems in every arena of our economy. Applications range from telecommunications, aerospace, homeland security, biomedical, and dental. Genial resin nanotechnology provides composite resin with filler particle size that is dramatically smaller in size and can be dissolved in higher concentrations and polymerized into the resin system with molecules that can be designed to be compatible when coupled with a polymer and provide unique physical, mechanical, and optical characteristics. Patient presents with defective composite restorations and recurrent caries on the mandibular left first molar. Shade determination is performed before dental dam placement with a custom fabricated composite shade tab using Genial Universal Flow A2 and A3. After anesthesia is administered and the treatment site is isolated, caries detection is initially performed and recorded using an argon ion laser source, the Diagnodent by Cavo. After radiographic evaluation, a visual and tactile inspection of the defective restorations and recurrent decay is performed using 1112 Explorer by Ufridi. The existing composite restoration is removed with a high-speed composite removal burr by Brasler using a water spray. A second evaluation and identification of the carious tissue using the Diagnodent. The carious dentin is removed with the number 4 slow-speed carbide round burr by Brasler and visually re-examined. This process is continued until all the destructive demineralized process is eliminated. The composite restoration is removed with a number 2 high-speed round burr using a water spray. A bevel is placed on the buccal preparation to integrate and disguise the composite restoration, but not on the occlusal. And a final caries reassessment. The preparations are disinfected using a 2% chlorhexidine solution, Concepsis by Ultradent. Agitated with an applicator tip, rinsed for 5 seconds, and the excess water is vacuumed. A self-etch adhesive, Genial Bond, is placed on the prepared enamel and dentin surfaces with an applicator tip. Allowed to dwell 10 seconds, dried for 5 seconds using an Adect warm air tooth dryer, and light cured for 10 seconds. An initial thin layer of A3 shaded Genial Universal Flow is applied to the pulpal floor and adapted using a round-tipped instrument, an M1 by American Eagle. Also, a thin layer of A3 shaded Genial Universal Flow is applied to the axial wall of the buccal preparation and adapted to the cavity walls using an 1112 Explorer by Ufridi and light cured for 10 seconds. A second increment of A3 shaded Genial Universal Flow is applied using the syringe tip with an ergonomic design to improve the access while maintaining visibility. Adapting the material with 1112 Explorer tip and light cure for 10 seconds. An increment of A2 shaded flowable is applied with the syringe tip. Notice the sculptability and the thixotrophic property of this material. Thixotrophy is a structural breakdown of a material, so it flows when the material is stressed, and when the hydrogen bonding restructures, it becomes more viscous. I call it controlled fluidity. Studies by Yamazaki, Chi, and Felix indicate incremental restorative techniques are effective in improving marginal sealing. I continue to adapt the material using the fine tip of the 1112 Explorer. Notice I develop the anatomical morphological contours. I use a double-aught sable brush to adapt the material to the Cavo surface margin and an 1112 Explorer by Ufridi and light cure for 10 seconds. I now use an A2 shaded Genial Universal Flow and the successive cusp buildup technique with an 1112 Explorer tip and light cure for 10 seconds. Notice as I make the ridges, inclines, and planes, the material is easy to manipulate and sculpt, and each time I stabilize by light curing for 10 seconds. I continue to develop the anatomical form, placing increments of flowable and shape with an explorer tip. A final enamel layer of flowable AE genial universal flow is applied with an explorer tip to the buccal surface and adapted using a double-aught sable brush. Notice the optimal marginal integration from this controlled fluidity of the material and light cure for 10 seconds. Notice the stability of the material on the explorer tip. This characteristic allows precise placement. I continue to develop the ridges and planes with an A2 shaded flowable as my final dentin layer, developing the anatomical morphological characteristics, the planes, the ridges and grooves, and light cure for 10 seconds. I use an ochre tinted color modifier, placing it with a 08 endodontic file to create occlusal fissure staining, a very natural effect within the final dentin layer, and light cure for 40 seconds to stabilize the color. A final enamel layer and AE shaded genial universal flow is applied over the entire dentin layer, maintaining the anatomical morphological contours, and a final 2-minute post-cure which increases the hardness. Finishing is accomplished with a 30-fluted H274 tapered finishing burr by Brasseler. Notice the shape follows the occlusal anatomical contours. The buccal surface is contoured and smoothed with a 30-fluted DET9 needle-shaped finishing burr by Brasseler. A silicone-impregnated brush, a Composite Pro by Brasseler, is used to enhance the smoothness. A silicone point, an ET Illustra polisher, is used to give a high surface reflectivity while maintaining the precisely developed anatomical contours. An enhanced foam cup with loose abrasive diamond paste is used to create a high luster. The occlusion is inspected with the patient in an upright position in centric occlusion and inspected for any prematurities, protrusive and lateral excursions, and the restoration is inspected for prematurities. And the completed restoration displaying function with an optimal integration of anatomical form and color. A prerequisite of all biomaterials is adequate radiopacity to allow the clinician to evaluate and distinguish caries from the restorative material at recare visits, and also to detect voids, overhangs, and open margins. As you can see at this 3-month recare visit, genial universal flow has this requisite with radiopacity equal to enamel. Although not a panacea to all restorative challenges, the utilization of this nanoparticle hybrid flowable composite, genial universal flow, in this 3-month review demonstrates enhanced sculptability, the polishability of a microfill, the strength of a hybrid, and the ability to simulate the optical properties of the natural tooth. It is understandable that clinicians have uncertainties about selection of restorative materials and techniques to achieve optimal and predictable results for many clinical situations. Modern clinicians have many of the same clinical challenges on selecting the appropriate restorative material and treatment modality as their colleagues of the 19th century. However, advances in material science and technology have provided the 21st century clinician with the knowledge to transform the mechanical approach of operative dentistry into a biological philosophy, strategy, and design. Although the nanoscale is small in size, its potential is vast. Applications of nanotechnology in dentistry have only approached the horizon, with opportunities and possibilities for the future that can only be limited by our imagination. These next-generation flowable composites are not designed to replace other therapeutic modalities, but to supplement the services that are offered to our dental patients. Although the long-term benefits of this nanocomposite genial universal flow remain to be determined through clinical studies, the mechanical and physical properties suggest a promising future.